Okay, so let's take a look at, we call this formula mass. And this is something that you will need to be able to do when you're calculating the number of moles. Number of moles will be, that's something that you'll learn about moles in Chemistry 30S. So that's the next level. But we're gonna get you for that. So you have your periodic table handy. All right, we have a periodic table handy. So let's take a look at what is formula mass. So again, on your periodic table, I'm gonna use my favorite example, sodium. Sodium's a good example because it has, okay, what do we call that larger number? What do we call that? And what do we call the small number? This is the mass number. That mass number is also known as the atomic mass, also known as the atomic weight. Just so we are aware, these are exactly the same thing. They come in 3 different names. Okay? So mass number, aka atomic mass, also known as atomic weight. And then you have that smaller number. What do we call that? This is the atomic number, which tells you what? The number of electron, which is equal to the number of protons all the time, right? So how do you find the number of neutron? You subtract these 2, right? Okay, so what is formula mass? So let's use an example here. Let's use sodium chloride, because we're talking about a very common compound that we see. This is the most abundant, sodium chloride. So if you take a look at sodium on the periodic table, what is the mass number of sodium? 22.99. We round it off to 23, right? So you have mass number is 23, and then chlorine, the mass number. So you're using the mass number for this one, not the atomic number anymore. Okay? Chlorine, you take a look at your periodic table, it says 35.5. 35.45. We can just leave it as 35. That's the mass number.
Don't you have those backwards mass number and atomic number? Is it mass number on the bottom?
Yeah, it depends on the periodic table. See that periodic table? Small one on the top, big one on the bottom. Same thing with this one here that we have. But some periodic tables actually have the larger number at the top and larger number on the bottom. It all depends on what there is no convention for that one. So if you see a periodic table, you may see that this might be on the bottom. So don't think of it as the number on the top and the number on the bottom. Think of it as the larger number versus the smaller number. Okay? The periodic table that I have at home, and I have one in my shower curtain in my bathroom, in my kids' bathroom, is a periodic table, and it actually is this way. So it doesn't matter as long as you know which is which. Okay, so the formula mass is basically just the sum of the mass number of the compound. So the total would be 5 plus 3 is 8, and 3 plus 2 is 58. So this is the formula mass. Because remember, the formula, when you put Na plus Cl minus, you get NaCl. Remember, this is, again, just to review, this is the chemical equation, and the chemical formula is NaCl. Okay? And then you have, that's right, of the 2 atoms. So you have your formula mass is the sum, the total of the mass number. Okay? So this is actually a very useful information. So if you're looking at, let's say, measure out 5 grams sodium chloride, okay, then you could just scoop it out. 1 teaspoon is 5 grams, right? But you can actually do a lot of calculations based on that. You can go from grams to moles to volume, which is going to be a very useful information. So we need to know how to calculate the formula mass. Okay, so that's example. That's pretty simple. Now let's do example 2. Call that one example 1.
I have a question.
Yeah.
How to calculate atomic mass of an element, how to calculate?
You don't calculate it. Scientists have already calculated it for us, and they put it on the periodic table. You can actually.
I want to know
How do they calculate it?
Yeah.
Okay, so what happens is when Marie Curie discovered radium and polonium, where's polonium? Polonium is right there, PO. So what happens is when she was experimenting on an unknown element, they would do different measurements. They would do a flame test and measure the length and then the energy, and then do experiments where they burn it, they will evaporate it, they purify it, and so they will measure out before and after. Okay, so once they purified that element, and I'm using polonium as an example here, they will weigh out the pure element and in 1 mole. So this is actually, they say it's 209 grams in 1 mole. Mole is a whole different concept that you'll cover in 30S. And then so once they figure out, okay, every time I isolate this element and I use 1 mole of this element, I always get 209 grams. So then the formula is that the molar mass, or the atomic number, and the mass number must be that. And then they put it on the periodic table. And it takes years of experimentation for that to become finalized.
If I have more than one element,
Mm-hmm. That's our example too. That's a good question. Okay, let's do, let's do the same one for now. Okay, so let's use the same NaCl. Adam, how many salt would you like? Pick a number. 2? Just 2? Okay, let's do 2. It's a good question. So now you have 2 molecules of NaCl, right? You got 2 molecules. So Eden, tell me what would be the formula mass, and we're just gonna simplify it as Fm for now. What is the Fm of that? I'm asking Eden. You don't look like Eden to me, Muhammad. Eden? Yeah. Okay, now Muhammad, you can help her out.
It would be 160.
Yeah, that's right. Because we just calculated 1, right? And you just double it. So this will be 58 times 2, which is 116. Right? That's it. Okay, so let's do something a little bit more challenging. Let's take a look at something here. Let's do ammonium sulfate. Okay, so we'll call this one example 3, ammonium sulfate. So we're going to do 6 molecules of ammonium sulfate. But before we do that, can you actually break this up for me, please? Let's break this down. That means this is going to be decomposed. So this will be a decomposition reaction. So go ahead and break it down into its ion. So it will be something plus something. What will you get? Can you try that? Because you're going to write this down anyway. So I want you to try to break it down. Now you go, but how do I know the charges? You know those subscripts? The subscripts tell you the charge. So ammonium, somebody said ammonium is NH4. How do you know it's plus 1? Because there's no number after SO4. So that's just a plus 1. And then SO4, you see the 2? That came from the SO4 right there. Okay? So this is the chemical equation. Let's take a look at the chemical formula for 6 of those. So let's say now you have 6. So we're going to break it down into separate elements, right? So the atoms of nitrogen, hydrogen, sulfur, and oxygen. So those are the atoms of the elements. So let's first count the number of atoms. So how many atoms of nitrogen do you have? I'm going to go 6 times 2. It's 12. Let's take a look at hydrogen. 6 times 4 times 2 is
48.
40.
Okay, sulfur now we have 6 times only 1, and oxygen 6 times 4, 24. Okay, so let's total. How many atoms would that be? And you already did this in your quiz, right? So you got 90 atoms altogether. Now let's take a look at the formula mass of 6 molecules of ammonium sulfate. All of them, 6 of them. So we take a look at the N, okay? So I'm gonna put down here the FM. Okay, so for N you have 12. You already have 12. We counted it already. You're gonna multiply it by the mass number. Look at nitrogen. 14. You can use a calculator if you'd like. This is a big molecule.
Where did you get 14 from?
14, yeah, from the periodic table
Okay.
mass number, remember?
Yeah.
Okay, so hydrogen, you have 48 atoms times 1, that's the easy one. And then sulfur, you have 6 times, sulfur is 32. And then oxygen is 24 times 16. Okay, I want you to fill out those blanks there, and then you're going to find the total, and that will be the formula mass. So you may use a calculator if you'd like. If you have a calculator handy. Or you can do it manually if you'd like. What's the total?
I heard a number. I got 792.
Yeah, did everyone get the same?
Yeah, I got that.
So that is the formula mass. For 6 molecules of ammonium sulfate. So what if I now ask you this? What is the formula mass of 1 molecule of ammonium sulfate? Because this is for 6 molecules, right? We did 6 molecules. Yeah, you just divide it by 6. So then you'll go 792. You just divide it by 6, which is 132. So that is the formula mass for 1 molecule of ammonium sulfate. Okay? So that's it. That means this, again, I don't want to jump too much into Chem 30S, but this tells you that 1 molecule of ammonium sulfate, okay, is equal to 132 grams per 1 mole. That is why we need to do this. And that's all I'm gonna get into. I will let you guys explore that more in Chem 30S. Okay? We don't have time to learn everything that we're not supposed to anyway. Yeah, that's what that means. Comes in handy when you're measuring out your materials for experiments. Okay? So now that you know how to count atoms, you know how to write a chemical equation, you know how to write the name of the chemical formula, and you now can go back and forth. You see that? You can do the ions forming a product, or you can do a product breaking down into ions. We can do all that now. We've come a long way. So now we're gonna balance them. Any questions so far? I saw a hand up.
Yeah, why you divide like 719?
Good question. Okay, so remember what we calculated is 6 molecules of NH4SO4, right? So that is 792 formula mass, right? For 6 of them. It's kind of like if you buy 6 pencils for, oh, that's expensive. If you what can you buy for 7? If you buy 6 shoes for $792, how much would each pair of shoe cost you if they're all the same? Then you divide it by 6 and you get that. Yeah, make sense? Okay. Can you try? Let's go back to your quiz now. Let's go back to your quiz, and I'd like you on your own to try to calculate. You may not have enough space here. If you do, that's great. If not, put it on a separate piece of paper. Find the formula mass for the last one and B. So this one here, if you're writing a version 1, you won't have the same one. So I just want you to then copy it. Okay? So let's start with the first one right there. 4 Mg2 SO4 brackets 2. So can somebody give me the name of that compound? Magnesium sulfate. Why did I not call it dimagnesium? It is an ionic compound. Okay? Ionic compounds do not use the ditri. And that's something, again, that I noticed some people lost marks on the quiz because you use the ditri. Okay? Don't do that for ionic. Okay. Okay, so let's try these two now, please.
Can I ask you a question?
Mm-hmm.
What's the difference between sulfide and sulfate?
Big difference. So you can have sulfide. The sulfide is just S negative 2. Okay, it's a single atom of sulfur. Sulfide and then sulfite.
But I mean, like when you combine 2 elements, that's you can add I at the end.
Mm-hmm.
Right? What about 8?
8 is a polyatomic ion. And the ion 8 sulfate is a combination of something with oxygen. So SO4 negative 2 is sulfate.
Anything with oxygen, it's 8.
Yeah.
And what about I?
And then not any, like ite is SO3, right? Instead of SO4. And it becomes an ite, but it still has an oxygen, so it has the T, the TE. It ends with the TE.
Still confusing.
I know. So again, you don't have to memorize them. You'll have to look it up on the polyatomic sheet. Yeah. So don't worry. You'll always have this. So there's that one there. Sulfate is SO4 negative 2, and then you have your sulfite is SO3, right? And then you have sulfide is just negative 2. So yeah, be mindful of the actual word.
There's a negative 2 charge. You use I.
I'd. Mm-hmm.
And then sulfite is 3.
Yeah. Yeah, same thing there with the 3, and then with the 4 is 8. But not always, because silicate is SiO3. Right, that one works with phosphate. So, yeah.
Oh, sulfite. Okay, let's see.
So, don't memorize it. You're looking at the formula mass for this one, but first you need to find the number of atoms, right? Okay, so let's list the elements: magnesium, sulfur, and oxygen. All right, how many magnesium do you have? 4 times 2, 8. Sulfur, 2 times 4, 8. Oxygen, 4 times 4 times 2. 16 times 2 is 32. How many atoms altogether? 48 atoms. Now, to calculate the formula mass, you're going to multiply them by the mass number. Okay, so we look up magnesium is 24. Okay, so you look at the number, this is the formula basically, the number of atoms multiplied by the mass number is the formula mass. That's how you do it. So if you want to remember that, you take the number of atoms times the mass number. Okay. Sulfur is 32, and then oxygen is 16, Okay, who's got the number calculated? You already have it. Yeah, you already did it from the quiz actually, right? So what's the total? Oh, what's 8 times 24?
192.
Okay, and then what's 8 times 32? 256, right? And then 32 times 16? Huh? 512, so that's a big one. Big molecule. Altogether? 960 formula mass. 960 grams per mole. That's what that is. Okay, it's almost a kilogram in 1 mole of that. Okay, so we're okay to move on, and I think you can do this, no problem. Let's do that. If you haven't done this yet, I want you to try it, and I want you to make sure you get it by the end of this class. Okay, so go ahead and write down beryllium, boron, and oxygen. I'm gonna give you a chance to finish this. How many of you are done the last one? I want to make sure you try it first. Okay, all right. I'll give you 2 minutes. Is that quick? 260?
No, 216.
Oh, 216, yeah.
176. 768. 1160. Divide 8 120.
$146.
45.
Okay, 146. $146. Try it. Oh, this is 1160, not 1168. That's why. So it's 140, 145. Did everyone get this?
Not everybody has the same one.
Why not? Let me double check. So 24 times 9.
Is that from the quiz?
24 times 9 is not, what?
It is. 216.
Yeah, 216.
That's right.
Yeah, that's right.
That's right.
1160. So 1 molecule, you divide it by 8, 145. Okay? Good to go? All right. Now, balancing. You see this number right here? Only if I ask you what is the formula mass for 1 molecule. If I don't ask you that, you don't have to write this down. Yeah, so this is the formula mass for 8 molecules. Okay? Are we okay? Sometimes you don't ask questions. If you don't ask questions, I assume that you know. Questions are good. If you're not sure, you ask questions. Okay?
This is from a review, right?
Yeah, that's from the quiz.
How did you do the
Not all
16
got the
or
same
the?
quiz.
It's not the same one, that's right. So you can just copy that particular molecule that I'm writing here.
How did you get the 16 on the?
16, see the right here, boron is 2
Yeah.
times 8.
Okay.
Everything, that number, everything is multiplied by 8.
48. And I guess 24.
So, yeah, 24 for beryllium, but the oxygen is 3 times 2 already, 6 times 8. Yeah, got it. Okay, let's get to the balancing chemical equation part. It is on, oh, question Mardos? Where did we get this? You total. This is the total. You add them all up. 1160 is the total. And then so this one here. Yeah, so this is you count the number of atoms, you multiply it by the mass number, and that's how you get the formula mass. That's the formula right here. This 8, if I want you to find the one molecule, because right now you have 8 molecules here. In our example, you got 8 molecules of beryllium borate. You got 8 molecules. You see that coefficient in the front? The number 8 at the front tells you the number of molecules of the whole thing. Okay? So there are, we didn't count the number of atoms we didn't count. So it would be the total of these things. That's the number of atoms.
88.
It would be 88, yeah. Last chance to ask. We're good? Okay, so let's get back to the balancing chemical equation. So this is where we left off yesterday on page 20. So again, the trick is to count. Now this was your homework, remember? So how did we do? Let's take a look at number 1. Okay, so balance, you're using a pencil, right? With balancing, it's best to use a pencil. Take a look at the reactants here. How many calcium? 1. How many oxygen? 1. How many hydrogen? 1. One of each. In the products, you got 1 calcium, 2 chlorine, 2 hydrogen, and 1 oxygen. So we have some issues here. It's not balanced, obviously, right? You see the number 2, you got 2 hydrogen on the right. I need to make hydrogen 2 on the left by putting 2 right here. Does that make sense? So you can only add coefficient, not subscripts. So by doing that, you change the number of hydrogen from 1 to 2. And chlorine also changed from 1 to 2. And you're done. So you only had to add that number 2.
How did you balance it?
Okay, let's do the second one. Take a look. Second one. Everyone. Sodium. This is the reaction that you're looking at. You have 1 sodium, hydrogen, 2, sulfur, 1, and oxygen, 4. Let's do the product side. Sodium and 2, 2. S, only 1. Oxygen, 4. And hydrogen, 2. Now, if you take a look here, the simplest ones are sodium and hydrogen. Leave the Na and H2 until the very end, because when you manipulate those two, nothing else gets affected. So save them till the end. So let's take a look at what is the issue here. What's not the same? Oxygen's the same, sulfur's the same. Sodium. So let's deal with sodium first. Now that's the only thing we need to do. So that's the only choice now. Sodium 1 here and 2 in the product. I need to make this 2 by putting 2 here. Now sodium is now 2. And that's it. We're done. Does that make sense? So you need to practice now. You know how to do this. How do we get faster so you don't run out of time on the quiz or the test? Is you practice. Okay? If you're running out of time, that means you haven't done enough practice. That comes with practice. Okay? Can you try this one? 1 for the road. We got 5 minutes left. Let's do number 3. And what I'll do then is I will just put the answers to here all the way to the end of page 23. And you can practice them. You can do them at your own time, but we'll still do it tomorrow. Don't worry. We'll still cover these tomorrow. Okay? Be prepared to do a hand-in assignment tomorrow. hand-in assignment, okay? So that's like one step to a quiz. So I'll give you some questions on balancing, and you're gonna hand it in for marks tomorrow, so you need some practice time tonight. Let's do one for the road. Copper, 1. Oxygen, 1. Carbon, 1. Copper, 1. Carbon, 1. Oxygen, 2. Okay, so how do we do this? Make oxygen 2 by putting 2 here. So oxygen is now 2, but copper also became 2. So I put 2 right here to make this one 2, and we're done. Yep, so I'll post the answers so you guys can check. Yeah, you're just making it the same. Law of conservation of mass. And we just have to do this, and we're almost done book 2.
How did you get PCL?
Yeah, just counting atoms. We got one more little section. So next week we should be able to finish chemistry. Your test should be on Monday the week after. So so you can schedule not this coming Monday. So your schedule should be what's the date? So tomorrow, no school Friday. Your test should be March 23rd. So you can actually take a look at your schedule now. So your chemistry, I'll put this in the blog as well. Your chemistry unit test is on Monday, March 23rd. Okay? So if you have a busy schedule, you have to make sure that you start studying a little bit every day. Don't be like, oh, I had to work the day before and then I wasn't able to study. You study along the way. Okay, little bits every day. And we got one more book to cover. Yeah, you will be getting a